Okay, so since we found one sign change, there's one negative real zero. And now we will use synthetic substitution to test some possibilities of the zeros for this function. Okay, so we're just going to try any random zero that we think might be a possible zero. So let's just try, and we want to try a positive number since we're looking for a positive real zero. So we're going to try 2 first. We'll bring the 1 down in synthetic substitution. 2 times 1 is 2. 0 plus 2 is 2. 2 times 4 is 4. Negative 15 plus 4 is negative 11. Negative 11 times 2 is negative 22. And 38 minus 22 is 16. 16 times 2 is 32. And here we would get negative 28. This number, the remainder, has to be 0 in order for the number that we're putting in there to be considered a 0. So this case, 2 is not. So now let's try 3. So we bring down the 1. Bring down the 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 15 plus 9 is negative 6. Negative 6 times 3 is negative 18. 38 minus 18 is 20. 20 times 3 is 60. And we do get 0. So 3 is a 0 of the polynomial function. Now we're going to try synthetic substitution again to find a 0 of the depressed polynomial. Remember from the other day when we were using synthetic substitution, whatever's left is called the depressed polynomial. So since 3 was the 0, the depressed polynomial was 1, 3, negative 6, and 20. So we use those numbers, coefficients, to find our negative. Okay? So all we're going to do is try a random negative number, and let's try negative 4. So bring down the 1. 1 times negative 4 is negative 4. 3 minus 4 is negative 1. Negative 1 times negative 4 is 4. Negative 6 plus 4 is negative 2. Negative 2 times negative 4 is positive 8, and that gives us 28. So negative 4 is not a 0. Now let's try negative 5. Bring down the 1. 1 times negative 5 is negative 5. 3 minus 5 is negative 2. Negative 2 times negative 5 is 10. Negative 6 plus 10 is 4. And 4 times negative 5 is negative 20. So negative 5 is another 0. Okay? And now the depressed polynomial that we have left is, or would be, x squared minus 2x plus 4. Okay? Now, there's 2 ways that we can figure from here. But once we get to the quadratic function, we want to use all our skills that we've learned in the past. If we can factor it using the x method, we do. Here we can't. And that's why it says to use the quadratic formula. We could use the quadratic formula also, or the other step that we could use is completing the square. I'm going to show us completing the square because it will help on the homework when we're trying to work backwards from the zeros to writing the polynomial. So the first thing we'll do here is to subtract 4 from each side, and we end up with x squared minus 2x equals negative 4. Okay? So from here, if we go back to our unit where we were completing the square, we always divide by 2. Whatever b is, we divide it by 2, and then we square it. Okay, well here, b is 2, so 2 divided by 2 is 1, and then when we square 1, we still get 1. So we are going to add 1 to both sides, because whatever we do to one side, we have to do to the other. Okay, now the reason we did that is because we know that this is a perfect square trinomial, hence the term completing the square. So this will factor to x minus 1 squared, which equals negative 3. Okay? So from here now, we are going to solve for x. So since we have x minus 1 squared, now I'm just going to go ahead and rewrite it since there's a little bit of scribble in the way. So we will take the square root from that side and end up with x minus 1 equals the square root of negative 3, which turns into the plus or minus I square root of 3. And our last step would be to add 1 to both sides. So x equals 1 plus or minus I root 3. And now we have found that x equals 1 plus or minus I square root of 3. X also equals negative 5. And x equals 3. So we have our 4 zeros, 1, 2, and then there's 2 zeros right here to make 4. So now we used everything that we learned in the past to find the zeros for any of the polynomials that have a degree higher than 2. Okay, and we can use all of our skills that we've learned in the past for factoring in order to do this.